Hello everyone. Today we're looking at the Leetcode question, middle of the linked list. Okay. So we are given a linked list and we have to return the middle element of the linked list. That means if there are five elements in the linked list, we have to return the third one. Okay. And if there are six elements in the linked list, six nodes, we have to return the second middle as it is having two middle nodes. We have to return the second middle node. Okay. As it is mentioned in the question, if there are two middle nodes, return the second middle. Okay. Now the first approach is the brute force approach, where we are going to count first the number of elements. Let's say we keep a pointer here, let's say p, and move p, uh, move forward p until p becomes none. Okay. Is p none? No. Therefore, we increase the count. Okay. Now move p to the next. Is p none? No. Therefore, we move p to count, increase the count, and move p to the next. Is p none? No. Therefore, increase the count and move p to the next element. And then for is it? This is also not none. Therefore, 5. And now p becomes none. Okay. I hope you know the algorithm to count the number of nodes. If not, we will see while coding. Okay. Now we have the count. We have the count of the elements as 5. Now to know the middle of the element, we will divide 5 by 2. Okay. If we divide 5 by 2, we will get 2 as output. Okay. And now what we are going to do is, we are going to put p back again at the head position. Okay. And move p two times from here. So p moves once and twice. Two times. One, two. Therefore p comes here and we return this element. Okay. This is how we reach the middle of the linked list in brute force approach. First we count the number of nodes, then we divide it by 2 and bring p back to the head, and then move p the mid number of times we get. Okay. So in Python we can solve this question uh, by doing this. Okay. So first we have to count the nodes. For that we have to initialize this variable c for counting as to 0. Place p pointer on head and let's start. While p is not none, that means until p becomes none, it will move. Okay, it will count, it will increase its count, and p will go to its next element, p dot next. Okay, therefore after this while loop, we will have the total count of the nodes. Now what we will do is m equal to c by 2. Okay, there what we'll do, this is this portion, middle. Okay, we for this example 5 by 2 becomes 2, and what we're going to do is place p back again on the head element. Okay, therefore p equal to head again. Now what we're going to do is, while m greater than 0, we will move p to the next element and increase m. Okay, that means at first m was 2, now p was here. We at first we move p to the next element and m becomes 1. Now comes to the next element, m becomes 0. And when it becomes 0, it will terminate. Okay, this is the loop. Now we may return p. Let's run it. Okay, while m, okay, it should be m minus equal to 1. I am subtracting by 0. Now this has passed. Now you will submit. Okay, it is accepted. Now this was the brute force approach where we are traversing the whole array once and then again up to the middle part. Okay. Next we will look at the optimal approach. Okay, now we are moving into the optimal approach, but for that you need to understand one concept that uh, suppose there are two people, person A and person T. Okay, let's say A runs at the speed of 2 kilometer, let's say 4 kilometers per hour. Okay, and T runs at the speed of 8 kilometer per hour. That means the double of A. Okay, so after 1 hour, let's say A has covered this much distance, 4 kilometer, and after the same time, that means 1 hour, T would be covering 8 kilometer. Okay, that means uh, yeah, if you observe it closely, for the same time, same time, 1 hour, if the speed of one person is double, the other person would have covered exactly middle of the path that the other person has covered. Okay. If you understand the question, we can apply it here. Let's say this is the T and this is the A. Okay. What we will do is we move T in a single iteration. We will move T twice. Okay. We will move T twice. Like for the first iteration, A will move here. Okay. And T will go directly here. Now, uh, for the next iteration, A will move here and T will move here. Okay. Now we can see that the next of T is none. That means T can't move any further. That means this is the total distance a pointer can move. Therefore, by applying this uh, intuition, we can say that the node at which A is currently, that is exactly the middle node. Okay. I hope you understand. This is the same concept as this one, that for the same time, if one someone's speed is double, then the other person would cover exactly half of the distance. Here, speed is double. The speed of T is double as A is moving only one node at a time, and but T is moving two nodes at a time. Therefore, until when T reaches the end of its iteration, A will be at the middle of the linked list. Okay, let's take another example for 6 nodes, like this one. It's 1 and 2, 3, 4, 5, 6. Okay, now 1, 2, 3, 4, 5, 6. This is the head, and we put T pointer here and A. Okay, T will move twice, A will move once. Okay, now T will move twice, A will move once. T will move twice, here it is none, and A will move once. Now T has no place to go further, therefore the node at which A is pointing, that is exactly the middle one. Okay, so for we you may ask that how much still T should iterate. That means T can iterate while uh, T is not none and T dot next is not none. I hope you understand that. Uh, for this example, T becomes none, therefore stop, and for the previous example, The next of t becomes none, therefore we stop. Okay, this is the condition. So to code it, uh, let me reset this code. The formal name or the actual name for these pointers are slow pointers and fast pointers. Therefore, we point slow at the head first, as all both of them are starting from the same position, the head position. Okay, while fast is not none and fast dot next is not none. Okay, what we'll do is slow will move once, slow dot next, and fast will move twice. That means fast dot next dot next. Okay, therefore we can say that uh, till when this loop will terminate, the node on which slow is pointing, that will be the exact middle. Then we can that means we can return slow directly after the loop. Okay, let's run it, and the test cases are passed. Then X submit, and it is accepted. Okay, so thank you for watching. If you find this video helpful, please subscribe to the channel.